this video, we're going to talk about looking at the confidence intervals for a population proportion. We've already talked about population proportions, but let's just go back over some of the items and notation for population proportions. Remember that P is equal to your population proportion, and we're talking about specific categories. X is equal to the number of individuals in a sample for who's in that specific category. N, as always, is just your sample size. And P hat is your sample proportion of individuals. We can find P hat by taking X divided by N. So in other words, the total number in your sample size and the number in that particular category and dividing those two. Now, when we're talking about confidence intervals, recall that we need standard errors and margin of errors. For our standard error for proportions, what we're going to do is we're going to find P hat times 1 minus P hat divided by N and take its square root. This is like finding the standard deviation and taking the square root of it. And then for the margin of error, we're going to multiply that by the z alpha divided by 2. And so we're going to take P hat 1 minus P hat divided by N. Okay? There are some assumptions that we make regarding the confidence interval for P. We have a simple random sample, meaning it's not specifically chosen, it's just a random sample. The population is at least 20 times as large as the sample, meaning we want it to be large enough so that we can assume that it is normally distributed. If it's not normally distributed, then we cannot use the z-score. Items in the population are divided into two categories. If there's more than two, then we have a little bit of trouble. We cannot just use P and 1 minus P. Sample must contain at least 10 individuals in each category, so we're assuming that there are at least 10 in each category. For the procedure for constructing a confidence interval, we're doing the exact same type of procedures. We need to compute the value of the point estimate, which is P hat, which recall is our X divided by N. We need to find the critical value, alpha divided by 2, for the desired confidence level. We compute the standard error, which recall I just said was P hat times 1 minus P hat divided by N, and we take its square root. And we multiply that by the critical value. This will give us the margin of error. So z alpha divided by 2 times square root of P hat 1 minus P hat all over N. That gives us that margin of error. And then we're going to construct the confidence interval. Here we're using P hat because that is the same thing as our sample mean minus my margin of error, z alpha divided by 2, P hat times 1 minus P hat divided by N, and take the square root. Looking for the mean. And we do the same thing on the other side, except for we're adding z alpha divided by 2 times P hat 1 minus P hat divided by N, take the square root. Here we also need to interpret our results. And for proportions, we're going to always round to 3 decimal places. So round to 3 decimals for proportions. Okay? So let's look at an example. And in this example it says, a survey of 145 randomly selected students at one college showed that only 87 checked their campus email account on a regular basis. Construct and interpret a 90% confidence interval for the percentage of students at the college who do not check their email on a regular basis. So we have a total of 145 students. You have to be very careful on this particular problem. It tells us that 87 check their email. We want to know how many do not check their email. So x is actually equal to 145 minus 87. So x is actually equal to 58 students. 58 students do not check their email on a regular basis. So you have to be a little bit careful there. You cannot just say what numbers are in the problem. You have to read the question carefully. So if 58 people do not check their email correctly, or on a regular basis, that means that p hat is 58 divided by 145. So p hat is equal to 0.40. We want to construct a 90% confidence interval. Well, we go over and look at a 90% confidence interval. 90% confidence interval, a z-score is 1.645. So we're going to use z alpha divided by 2 is equal to 1.645. So we have the information that we need because we have p hat, we have n, and we have z. Because our confidence interval is p hat minus z alpha divided by 2 times p hat times 1 minus p hat divided by n, take the square root. It's going to be less than mu, less than p hat plus z alpha divided by 2, p hat 1 minus p hat divided by n, and take the square root. So we're going to do 0.40 minus 1.645, and I'm going to put 0.40 times 1 minus 0.40 divided by 145, because that's how many total students we're looking at. It's less than mu. And the other side is going to look like the exact same thing, plus 1.645 times 0.40 times 1 minus 0.40 divided by 145. I'm going to go ahead and calculate my margin of error first, which is going to give me a 0.067. And I rounded it to 3 decimal places because remember that we are looking at 3 decimal places. And so when I add and subtract that from 0.40, I will get 0.333 and 0.467. And so with 90% confidence, the proportion of all students at the college who do not check their email regularly is between 0.33 and 0.467. Just like with the standard normal curve, we can also find the necessary sample size, which is going to be n is equal to p hat times 1 minus p hat times z alpha divided by 2 over our margin of error squared. Now, sometimes we may not have our p hat. If we do not have our p hat, assume that p hat is equal to 0.5. That is if you do not have your p hat. So let's look at an example. And so a market researcher wishes to determine the proportion of American women who shop online. The results must be accurate at the 90% confidence with a margin of error of 2%. Calculate the minimum sample size needed to meet these requirements, given that a previous study estimated that 59% of American women shop online. So our margin of error is 2%, that is 0.02. My sample proportion is 59%, which is the same thing as 0.59. We're looking at a 90% confidence interval, which we just previously used, so that z alpha divided by 2 is 1.645. So the sample size that I need is going to be 0.59 times 1 minus 0.59 times a 1.645 divided by 0.02, that quantity squared. So I'm going to take 1 minus 0.59, which is 0.41, times 0.59. I'm going to divide these two, which will give me 82.25. I'll multiply these two, which will give me 0.2419. And I'll square the 82.25, which will give me 6765.02, I'm sorry, 0625. I need to square that value and multiply it by the 0.249. So square this value first and then multiply it by the 0.2419. And you get 1636.46819. Remember, we're talking about sample size, so we're always going to round up to the next number. And so 1,637 American women need to be sampled. Practice some of the proportion, confidence intervals, and sample sizes. If you have questions, let me know.